It is time for lab number 11, in which we are going to finish out the axial skeleton. Jog your brain for a second. Remember, the axial skeleton is the skull, the vertebrae, the sternum, and the ribs. Last two labs, what did we do? We did the skull. So today, we got to do the vertebrae, we got to do the ribs, we got to do the sternum. All right, we are starting with the vertebrae. So here I am looking at a superior view of a single solitary vertebra. If you are a grown-up adult person, you are going to have a total of 26 bones in your vertebral column. Most of them are kind of like this. So 24 of them are more or less like this. There's a couple weird ones. But then there's two that are definitely different. But 26 total. So 26 bones in the vertebral column. Just like there's 26 letters in the alphabet. It's an easy number to remember. And you can already see there's this hole right here. Spinal cord is going to run through that hole. The ring of bone around it protects the spinal cord. Plus, we have all these sticky out things that muscles are going to attach to. Now, as we discuss the vertebral column, we're going to see there are different vertebrae in different regions of the body. So, for example, in the neck, we're going to have 7 cervical vertebrae. In the chest, upper back region, we're going to have 12 thoracic. In the lower back, 5 lumbar. Then below that, we're going to have a single big bone called the sacrum and a single kind of little bone called the coccyx. So we're going to look at all of these different things. This guy right here, this is like the quintessential vertebra, and it is a thoracic vertebra that we're looking at right here. All right. So let's start looking at the basic components of a vertebra. So right here we have this thoracic vertebra. It is a lovely, perfect specimen. In this red dashed line, this heart-shaped thing is the body. That is the biggest part of the vertebra. It is going to be spongy bone on the inside with compact bone on the outside, which is basically the way just about every bone works. And these vertebral bodies, they are going to support the weight. Okay, they're going to support the weight. They're going to support your body. Now, attached to this guy, we don't see it here, but attached to this body, so sitting right on top of it, for example, would be a pad of fibrocartilage called an intervertebral disc. And we'll look at a picture that has some of those in a moment. So we have these pads of fibrocartilage, this really strong cartilage between the vertebrae, which are going to give us some cushioning, some shock absorption, and going to allow a little bit of movement. If we look at 3 lumbar vertebrae, so I got 3 lumbar vertebrae right here. And these 3, I can see 3 bodies, 1, 2, 3. 3 bodies of those vertebrae. So in between them, this guy right here is an intervertebral disc. This guy right here is an intervertebral disc. These are pads of fibrocartilage. Think about fibrocartilage as like cartilage with an extra helping of collagen. So extra collagen fibers give it the prefix fibro. And that makes it extra strong. Now, since we do have these articulated vertebrae, these joined vertebrae, I do want you to notice how you can see this nice hole that is formed between vertebrae right here. This is called an intervertebral foramen, the hole between the vertebrae. And this is actually going to be where spinal nerves are going to exit and enter the vertebral cavity. So like get in and get out of that spinal cord. All right. Let's go back to our basic vertebra. Whoops, I guess I didn't clear my drawings. There we go. So we did the body last time. So this thing down here was the body. And emanating from the body, we got this whole semicircle right here. This whole semicircle is the vertebral arch. So it is going to surround this passageway right here called the vertebral foramen. So the vertebral arch surrounds the vertebral foramen. What's going to be inside the vertebral foramen? What's this arch protecting? If you said spinal cord, you just got it totally right. Now, the vertebral arch is made up of two things called pedicles and two things called laminae. So we're going to look at pedicles and laminae in a moment. So let's do that. Oh, before we do that, here's that vertebral foramen. I mentioned it earlier. I got a whole slide devoted to it here. Together, all of the vertebral foramina are going to make up the vertebral cavity. And the vertebral cavity, of course, houses the spinal cord. All right, this little guy right here, this little bit of bone, is one of the pedicles. There's another pedicle over here. Another pedicle. The pedicles are directly attached to the body. So the pedicles are the first part of the arch that comes off the body. Now, what does the pedicle mean? What's ped mean in pedicle? I bet you know what this prefix ped means, this root word means. Think about it. You're a biped. You've probably been a pedestrian. Maybe you got a pedicure. Ped means foot. So these are the little feet emanating from the body. Okay, those are my pedicles. And up here, this chunk, and also let's draw the other chunk. Let's not just have one chunk. Let's draw two chunks. There's the other chunk. These are my laminae. One would be a lamina, two are laminae. They're kind of thin, and the word lamina means like a thin layer. Like if you laminate something, you put a thin layer of plastic on it, right? So these are my two laminae. So overall, my vertebral arch equals my two pedicles plus my two laminae. It's like we're doing some algebra here. You could rearrange this equation. I'm just kidding. Okay, so the laminae and the pedicles, they form this arch which protects the vertebral column. And the laminae and the pedicles are also going to have some things coming off of them. In fact, there are 6 things that come off the vertebral arch. There's 1, 2, 3, 4, 5. Those last two, 4 and 5, are actually like coming out at you right now. And then you can see down here, there's like a little hint of, I think I messed up my counting, 5 and 6. So hold on. Let's number them. 1, 2, 3. Yeah, there we go. 4, 5. So 4 and 5 are the ones coming out at you. No, I did it again. Did I do it again? Yeah, I did. I cannot count tonight. I cannot count tonight. That's what it is. That's my problem. 6, 7. There's 7 things coming out. Did I say 6 earlier? Yeah, I think I did. But we're already 10 minutes in, so I'm going to let a little mistake go. As long as I correct it, it's all good. That's what I get for doing a video like at the end of the day. Should do it bright and early in the morning. Easier said than done, right? Okay, so there are 7 sticky out things that are going to attach to muscle and also help lock vertebrae together. So we're going to notice that Of these seven processes, these guys are for muscle attachment, generally speaking, and these guys are generally going to help lock vertebrae together. All right. Let's keep on going. Let's talk about some of these processes. So, we had the pedicle, right? Pedicle. We had the lamina, right? Basically, right where the pedicle and lamina meet, there is a sticky out piece to the side. And we get this on both halves here. And these sticky out guys are called transverse processes because they're on that transverse axis of your torso. These are going to be for muscle attachment, primarily. These are for muscle attachment. In the thoracic chunk of the vertebral column, these guys are doing double duty. They're not only for muscle attachment, but they're also going to articulate with a rib on each side. And we'll see how that works later on. All right. This guy in the back is the spinous process. It is going to be for muscle attachment. If you palpate your own back, especially if you lean forward, I bet you can feel the spinous processes. I'm doing it right now. I'm feeling all my spinous processes. It's always good if you have a bony person that can be your study partner so you can, find all these things. If you have a spouse, significant other, sibling, child, use them and be like, hey, I'm going to study. Come here. And find all these things on them. So, spinous process in the back, transverse processes to the side, body in the front. All right, we've now switched views. Earlier, I was looking at a superior view of a thoracic vertebra. Now I got a lateral view of a lovely lumbar vertebra. And I got the same one twice here. And in the lateral view, we can still see a lot of the same stuff. So we can still see the body right here. We can still see the spinous process going backwards. This is actually the transverse process right here. He's coming out at you. But in this lateral view, we can see what's called the superior articular process. And we can see two of them. So I'm going to label both of them. So two superior articular processes. I can also see one of the two inferior articular processes. Okay, check this out for a second. The purpose of these guys, the purpose of this superior one right here is actually to make an articulation, a joint with the inferior one above it. And that locks these bones together. Okay, who is more bendy? Who is more bendy, you or a snake? Who can bend their body better, you or a snake? It's an easy question. The answer is a snake. The thing is, snakes don't have these articular processes. What that means is they don't have anything really locking their vertebrae together, so they're super bendy. But you don't want to be super bendy because that would compromise your structure and compromise your support. So you have these superior articular processes, and they will interlock with these inferior ones, and that locks your vertebral column together. Now, it's not totally rigidly locked so you can't move at all, but it does restrict your movement to a degree. And what that restriction of movement is going to do, it is going to increase the support. Fantastic. Awesome. Oh, you know what? Because these superior and inferior articular processes, because they form joints, and because there is some movement at those joints, these processes need a smooth surface. So this blue arrow right here is on what's called a superior articular facet. This is the smooth part of the process where we form the joint. Hey, by the way, good rule of thumb. If you're making a movable joint, you want smoothness for sliding. If you're just for like muscle attachment, you want roughness for grabbability. So we're going to see the spinous process, for example, it's not going to have any smooth parts. It'll generally be more rough, which will make it easier for tendons to grab upon it. But my superior articular process needs this superior articular facet so it can slide with an inferior articular facet above it. Because remember, these guys interlocked to give us stability, but we still allow some movement. All right, this is good. This is a lot, but it's good stuff. Let's actually, let me see here. Let's do one more slide. I want to backtrack for a second. I got my same lumbar vertebra right here, and I just want you to notice that between the body and the inferior articular process is this little indentation. This is called the inferior notch. And when we stack vertebrae, when they're articulated, that inferior notch then becomes part of the hole that we saw a couple minutes ago called the intervertebral foramen. Let's go back for a quick second and look at those stacked together ones. So bear with me here. There they are. So we've got 3 stacked lumbar vertebrae. First of all, check this out right here. What this is, it's showing you that the superior articular process is articulating with the inferior articular process. We don't see the smooth faces because they're like right against one another. But we can see they're interlocking right there. We can see them interlocking right here as well. And that's a joint that restricts movement and thus increases stability, but still lets you glide a little bit. I mean, you can still like bend forward, bend to the side, right? Twist a little bit. And by the way, here's that inferior notch. We see that on this vertebrae because he doesn't have anybody below him. But when we have the 2 vertebrae stacked together, so the notch right there then becomes part of this foramen here. Okay, just wanted to run through that before we kept on going. And I think we're done our basics of our vertebrae. Yeah, we're done the basics. And now what we got to do is look at thoracics, look at cervicals, and look at lumbars. And then we'll take a look at our sacrum, and then the coccyx, and then the sternum, and then the ribs. That's all we got to do. That actually sounded like a lot. Okay, this is a lateral view of the thoracic vertebra. We can see some of our good old-fashioned regular stuff, like here is the body, here is a pedicle, here is a transverse process, here's the spinous process. Look at how it is angled down. Here's the superior articular process. Now the inferior articular process is right here, and it is actually fused with the spinous process. Now we don't really see the facets, but the facets are going to face out on the superior guy and forward on the inferior guy. And what that does is it lets you like bend in your upper back side to side more so than forward and backward. Okay, this is a thoracic vertebra. It is a beautiful thoracic vertebra. Do you see, I see a giraffe when I look at this guy. Do you see a giraffe? Like, I don't know, maybe his neck is like right there. Do you see that giraffe? And then the rest of his body is like that. He's got spots. Do you see the giraffe? I hope so. All right. Let's keep on going. There's a couple more neat things about the thoracic vertebrae. And I kind of hinted at this earlier because earlier we mentioned that these thoracic vertebrae are going to articulate with ribs. So what that means is there have to be sites for these joints to form. And there is a tiny bit of movement between your ribs and your vertebrae. So if we have a joint with a tiny bit of movement, what do we need? We need smooth faces, facets. And on each side of a typical thoracic vertebra, you are going to have 3 spots for rib joints. I want to point them out here. Right here on the body, near the pedicle, on the top near the pedicle, right there, that is what's called the superior costal demifacet. We'll break that word down in a moment. Down here on the bottom back of the, bottom like back corners of the body, we have an inferior costal demifacet. Okay, the word costal means of the rib. So these joints are for ribs, so they're called, we use the word costal here. Okay? Superior because this guy's on the top of the body. Inferior because this guy's on the bottom. And notice we have facet. Just like we had facets a moment ago. Remember we had superior articular facet, inferior articular facet. A facet is a smooth face. But we have this word demifacet. What does demi mean? Demi, hemi, semi, all basically mean the same thing. They mean like half, okay? And the reason being, when the head of a rib comes in, the head of a rib is actually going to articulate with 2 vertebrae at the same time. So here we have a head of a rib right here. This is the head of a rib right here. And although the picture isn't showing it, it's articulating with 2 vertebrae. It is articulating with this vertebrae right here that I'm putting number 1 on. And we can see that junction right there between the head of the rib and the superior costal, I can't make a C there, can I? Superior costal, oh, that's horrible. Superior costal demifacet right there. So I'm going to clear everything, okay? The head of the rib and the superior costal demifacet are uniting right there on this rib number 1. What we don't see is that underneath rib number 1 here, the same guy is going to be articulating with another rib, okay? It's going to be articulating with another one. So we are always going to, I don't want to say always, this is because it gets a little weird at the top and the bottom, but this is generally the way it works. A rib articulates with 2 vertebral bodies. So a rib head is attached with 2 bodies. That's weird, right? You expect 1 head, 1 body, but it is 1 head, 2 bodies. So the 2 bodies have to share the head. So the 2 bodies have to share the head. So each body has a pair of demifacets. Each of them gets half a head. All right, I know that sounded crazy complicated. We'll look at another picture in a moment. Come see me if you have any questions. I will try and unpack that further. Okay, on the transverse process, there is a transverse costal facet. This is also for a rib. This is a one-to-one relationship here. Every rib articulates with only one transverse costal facet. And in fact, there's a bump on your rib. The bump is called a tubercle. And the bump on the tubercle articulates with the transverse costal facet right there in my little circle. Okay, so bottom line, thoracic vertebrae have some extra structures for joints because thoracic vertebrae have to form joints with the ribs. And a typical thoracic vertebra has 3 of these joint surfaces on each side. There is going to be a superior costal demifacet, which will get half of a head of a rib. An inferior costal demifacet, which will also get half of a head of a rib. And a transverse costal facet, which will articulate with a tubercle of a rib. All right. Good stuff. Here we see it in action. This is beautiful. So what I'm looking at right here is a rib over here. Boom, boom, boom. There's a rib. Here is the head of the rib. And you can see the head of the rib. Since this is a model, it's not perfect, but you can see the head of the rib is going to articulate with an inferior costal demifacet on this guy, and then also going to articulate with a superior one on this guy. And you can see it a little bit more nicely in this picture. Over here, you can beautifully see the tubercle. There's a tubercle. I'm putting 3 dots on the tubercle. Articulating with the transverse process right there. So a typical rib is going to articulate with 2 bodies and 1 transverse process. All right. By the way, I am not going to kill you on an exam with this, okay? I know this can get confusing. I could make a super confusing question about this whole arrangement here, and I will not do that, okay? So don't like get hung up and try and spend like hours trying to understand this one part right here, okay? Because I'm not going to kill you on an exam with this, because I understand. But I do want you to get the general idea. Okay. Sweet. We are done with thoracic vertebrae. And now we got to do the cervical vertebrae. There are 7 cervical vertebrae. I almost forgot. There's a great mnemonic device. So 7 cervical vertebrae, you have breakfast at 7. 12 thoracic vertebrae, you have lunch at 12. 5 lumbar vertebrae, you have dinner at 5. 7, 12, 5. 3 meals right there. It's an early dinner, I know, but I'm usually kind of hungry around 5, so works out. Now, this is a typical cervical vertebra. You actually don't have all 7 cervical vertebrae that are typical. 2 are kind of weird looking. The first 2 cervical vertebrae are weird looking. Vertebrae C3 through C7, so 3rd through 7th cervical vertebrae, they are more typical. This is a typical one, okay? It has the normal stuff. So it has a normal body. It has a lovely spinous process. It has a lamina. It has a pedicle. It is going to have a transverse process that looks kind of wacky. It has a superior articular process as well. Now, some special unique things, okay? First and foremost, the transverse process gets a hole. The transverse foramen on each side. So every cervical vertebra is going to have a pair of transverse foramina. These are going to allow blood vessels, so there's a vein and an artery that go up through your neck to and from the back of your brain. There's also a big net of nerves, a plexus of nerves in here as well. So these transverse foramina are only found in cervical vertebrae. Okay, what else is unique about this guy? Look at the spinous process. It's got a bifid spinous process. This means it's split into two endings. This lets you get really good paired muscle attachment. So you got muscles attaching really well to both sides. You think about your neck for a second. Your neck is actually pretty mobile. You have good musculature on both sides. You also have really flat articular processes. So I see my superior ones here. The inferior ones would be on the opposite side. And they're really flat, so you don't have as much movement restriction and as much stability, but you do have more movement in your neck. Okay, so this is the typical cervical vertebra. Let's now look at one of the weird ones. This is one of the weird ones right here. This is our C1, our first cervical vertebra. It does not have a body. It doesn't have a body. Instead, what it has are these arches. Whoops. Thought I was drawing there. It's got these arches. It has an anterior arch, which I just put red dashes on. It has a posterior arch, which I just put blue dashes on. So normally the body would be right here, but there is no body. It does have a very important pair of superior articular facets, and we've actually kind of mentioned these guys already. These two guys right here articulate with the occipital condyle. So the occipital condyle is going to sit right here on each side. Remember, those are the bumps right next to the foramen magnum on the occipital bone. And they sit right here. If you are nodding yes, so go ahead and nod yes. Are you going to do well in this upcoming lab exam? And nod your head yes. When you nod your head yes, you are rocking your occipital condyles on your superior articular facets of your C1. Now, by the way, C1 is often known as the atlas. Remember that Greek mythology class you took? Did you ever take a class where you did the Greek myths? So there was this, if you know your Greek gods like Zeus and Hera and all them, before the Greek gods, there were the Titans, and the Greek gods kind of like overthrew the Titans. And one of the Titans was this guy named Atlas, and he was condemned by Zeus, so the father of the Greek gods, to hold up the heavens for all of eternity. So somebody back in the day decided to make a classical allusion here and say, hey, this first cervical vertebra holds up the skull. Let's call it the atlas. All right. Good stuff. I always like it when there's a fun story behind the name. Okay, so a moment ago I talked about that posterior arch. And on that posterior arch, which I just put some blue dashes on, there is this little bump called the posterior tubercle. There we go. Little muscle grabs onto it, helps you keep your head up when you got good posture and your head is up nice and tall. Okay. Anything else on this guy? No! We're done with C1. Fantastic. We got on to C2. C2 is the second cervical vertebra. It has some typical stuff. So it does have a body here. It does have a spinous process, a lamina. It is going to have a pedicle kind of in here. It's like the transverse process, kind of broken right here, but you can see it. You can see the transverse foramen right there. I put an arrow in that. You can see a superior articular facet. Again, notice how It's not much of a process because we're not restricting movement here, okay? So the atlas would actually be sitting down and forming a joint with these two superior articular facets. Now what's really weird about this guy is this structure right here. It's called the dens. The word dens means tooth in Latin, so somebody thought this looked like a tooth. The dens sticks up, and you can see how the dens, there's the dens right there in this picture, there's the dens. The dens is going to form an articulation with that anterior arch. And this articulation lets you do the rotational movement when you're saying no. So, if I was asking you, am I giving you too much stuff to learn? You would shake your head and say no. And you'd be using this joint here between C1 and C2, between the atlas and the axis. So things spin on an axis, right? So C2 is often known as the axis because it is a point of rotation. Okay. And folks, we are done cervical vertebrae. And now it's lumbar time. Lumbar vertebrae have nothing unique and weird. They got no like extra stuff. They got the body, got a pedicle, got a transverse process, superior articular process, inferior articular process, all the usual stuff. Spinous process right there. Fantastic. The facets rather, on these processes here. So we can actually see one of the facets right here because the facets on the bottom process go out. The facets on the top process go in medially. And this lets you bend forward easily, but have less side-to-side motion with this lumbar vertebra. And by the way, lumbar vertebrae are big. And this totally makes sense because they're supporting more weight. So it makes sense that the bigger vertebrae are down lower. Now to me, when I look at this guy, I see a moose here. Like it's like the antlers are up here and the snout is right here and like the jowls of the moose are down here. I see a moose. So I saw a giraffe earlier with the thoracic and I see a moose now. Alright guys, we are done all of the individual little vertebrae. We just did 24 of the 26 bones in the adult vertebral column, which means all we got to do is 2 more vertebral bones, the sacrum and the coccyx. So, this big bone up top here, this big guy right here, is the sacrum. The sacrum. And then this guy down here, let's draw around the whole thing. This guy down here is the coccyx. So sacrum and coccyx. They're both single solid bones. The sacrum is formed by the fusion of what were originally 5 sacral vertebrae in the child. The coccyx is usually formed by the fusion of 4 coccygeal vertebrae. Sometimes there's 3, sometimes there's 5, usually there's 4. The fusion actually takes a long time, usually not until your late 20s until it's complete. Why do we fuse bones in the lower column? What does fusion create? Give me an S word here. And I would take either strength or support because they're kind of going hand in hand here. If we fuse these bones together, we're stronger and we are going to be able to support more weight. Okay. The sacrum is called the sacrum. As the story goes, this bone used to be called the vertebra magna because it's so big. Now, when we think about the word big, it can have a couple different meanings, right? I could tell you, you have a big exam coming up, right? I could tell you have a big exam coming up. And that could have two two ideas there. It could mean like it's a really long exam, there's lots of questions and stuff. It could also mean it was important. And when we get that idea of the word important, we can then come up from the word important, we can come up with the word sacred. Things that are sacred are often important to people, right? So that is one of the major stories on why it's called the sacrum. I don't know if it's 100% accurate, but I like it because it's good. The word coccyx means the beak of a cuckoo. So if you're familiar with a bird called the cuckoo, maybe you've seen a cuckoo clock before. Somebody thought it looked like a cuckoo's beak. I got no idea if that's true. None whatsoever. I really should look at a picture of a cuckoo beak someday. I don't know why I haven't done that. All right, let's keep going. I know this is another long video. In the sacrum, we're going to see sacral foramina, so sacral holes, spinal nerves, and blood vessels are going to come out of here. When we turn the sacrum to the side and look anteriorly, we can see this jutting portion here. This is called the Sacral Promontory. It's where the pelvic cavity starts. It is an important landmark. If you go back to your geography class, you know a promontory is a piece of land that like sticks out into a body of water. So because of the sticky out nature of this, that's why they called it a promontory. Okay, this guy right here, the dashed lines, is called the auricular surface. Auricular means like a little ear. So use your imagination here. Maybe you can see an ear. I can kind of see an ear. Can you see an ear? I can kind of do it. And this auricular surface, so the auricular surface is right in where this red arrow is. It articulates with the iliac portion of the hip bone. So the joint right here is between the auricular surface of the sacrum and the iliac region of the hip bone. And this is called the sacroiliac joint. It is a pretty rough joint. Roughness is for stability. Think about the weight transfer from the vertebral column into the hips and onward into the legs. And we need a strong joint there to transmit that force. There is a little bit of gliding motion that's possible here, especially if it's a lady and she is pregnant. Then you can get a little bit of motion right there. All right, let's keep on going. Here's the back side of the sacrum. We can see those sacral foramina posteriorly here. Again, blood vessels and nerves. We see it like a crest made from the sacral spinous processes. And of course, we do see the coccyx down here. Coccyx doesn't really do much at all. Some muscles and ligaments attached to it. It is your tailbone. There is a joint right here. There's a pad of fibrocartilage here between these two guys. And so you get a little movement there when you're pooping, defecation, or when you're giving birth, parturition. If you don't know that word for giving birth, it's a new vocab word for you, parturition. Okay. Yes! Fantastic! We are done with the vertebral column. And that means we only have 25 bones to go. 24 ribs, 1 sternum. The 24 ribs, so 12 and 12, plus the sternum, plus all the costal cartilage. Remember that word costal? It meant ribs. Those guys collectively form the thoracic cage, protecting your lungs, your heart, other important organs. Also, a lot of places for muscle attachment on these guys. Okay, let's do the ribs first. Your first 7 ribs are called your true ribs. because because they all have their own piece of costal cartilage. If the first 7 are true, what do you think the next 5 are? You're right, they're false. Now, the first 3 false ones share a piece of costal cartilage. Then the last 2 false ones have no costal cartilage at all. Notice how the costal cartilage anchors the ribs to the sternum anteriorly? The first 10 are attached to the sternum, the last 2 are not. So we got 7 true, all attached to the sternum with their own costal cartilage. Then we have 5 false. First 3 false share costal cartilage. The last 2 false don't have any costal cartilage, so they are known as the floating ribs. Okay. We see the costal cartilage pieces here. This costal cartilage is hyaline cartilage, which has that nice blend of flexibility and strength. Think about taking a big deep breath in. You want some flexibility there. You know what's delicious? Ribs are delicious, right? Maybe you disagree with me here. I bet most of you agree with me that ribs are delicious. And when you're eating ribs, obviously you're not eating the actual bone, right? You're eating the muscle in between here. But I bet when you're eating the ribs, you've seen this cartilage, or you've bitten a little piece of this cartilage and spat it out or something. So if you go eat some ribs, you will probably see some costal cartilage. I'm not going to give you any extra credit for going and eating some ribs, but I highly encourage it because they are delicious. All right. We are flying along. And I know this is a long one, but we are almost done. Trust me, okay? We are almost done. Here I see just a single solitary rib. Head of the ribs in a circle right there. Head of the rib, remember, typically articulates with 2 demifacets on 2 different vertebral bodies. One of them being a superior costal demifacet. One of them being an inferior costal demifacet. So 1 head, 2 bodies, right? All right. And there is that little bump. That little bump on the rib is called the tubercle. The tubercle articulates with the transverse process. Check out how those T's together. Tubercle of the rib, transverse process of the vertebra. All right. Fantastic. And guys, we are on to the sternum. The sternum itself has 3 regions. The first region in this red circle is called the manubrium, which basically means handle. Like if you were to flip the sternum upside down and turn it into a dagger, this would be its handle. So that is the manubrium of the sternum. It is going to articulate with a clavicle and the first rib on each side. Below, inferior to the manubrium, we got the body of the sternum. So your next set, the rest of your true ribs are going to articulate with the body of your sternum. And then the final part is the xiphoid process. This little sticky down part right here. This is the xiphoid process. It typically does not turn into bone until you are in your 40s. So it is like one of the last parts of your body to change. Because when you were a tiny little fetus, you had a skeleton made of cartilage. And this is like the last bit to turn from cartilage to bone. The xiphoid process, xiphoid means like a sword. You might be able to feel this, palpate this in the bottom of your sternum. What does it do? It attaches to abdominal muscles. what you think about is your ab muscles, like the six-pack muscles. They come up and grab onto your xiphoid process, and then they pull it towards your pelvis, like if you're doing like a crunch type exercise. So that is the xiphoid process. And folks, we are done. I'm glad I didn't get to an hour in this one. This was a big one, I know. So hopefully you endured with me and you are learning these parts. Take care. Bye-bye.